In the last video, we looked at what happens when you add or subtract a number from x. Now let's look what happens if you put a negative in front of an x instead of a function. For example, f of x equals the square root of negative x. Instead of square root of x, it's going to be square root of negative x. Let's go ahead and see what happens. So right off the bat, we're going to go ahead and do f of x equals square root of x. Here we have right here. Now watch what happens when we put a negative 1 in front of the x. In other words, negative x. Look what happens to the parent graph. It was here, and look what happened. It flipped over the y-axis and it went over here. So it did a complete horizontal flip just by putting a negative in front of the x. Let's look at another example. See, next we're going to do negative x cubed. So let's go ahead and bring up x cubed here. And again, notice what happens. Let's start at b equals 1. Notice what happens when we make it negative 1. We take the original parent graph and effectively it flips over the y-axis, kind of like a mirror, and becomes this new s-curve. Finally, we're going to do 2 to the negative x. Let's see what happens when we flip 2 to the x and make it 2 to the negative x. Let's put b back equal to 1. Let's go over here. We're going to make 2. So here's 2 to the x. Now let's put a negative 1 in front of the x and see what happens. Okay, now we can see that b is equal to negative 1. And look, again, it flipped the whole graph horizontally over the y-axis. If you were to draw a dotted line down here, you would see symmetry between these two graphs on at x equals 0 or on the y-axis. So the real question is, why is this happening? We can see that when b equals negative 1, the parent graph flips horizontally. But why? We're going to show this like we did with adding and subtracting numbers from x. So our parent function in our first in the square root of x function, p of x equals square root of x. If I plug in 1, I get 1 back, right? Because the square root of 1 is 1. So the real question is, what happens when I plug in, when I put a negative in front of the x? Well, can you see that in order to get positive 1 back, instead of plugging in positive 1 to our transformed function, we'd have to plug in negative 1 because there's already negative there. And I know that two negatives make a positive, and therefore I get the same y value 1 back when I plug in negative 1. Then we can see the horizontal flip. In other words, I've got to change the sign of my x value to negative 1. I mean, if it was negative already, we would make it positive, but in this case it goes from positive 1 to negative 1 in order to get the same y value of 1. And we can see that in our graph. Positive 1 gives us 1, and on our transform graph, negative 1 gives us the same value. It's got to make up for that negative that's in front of our x value. Alright, let's look at another x value on the same graph. P of x equals square root of x. If I plug in 4, I get the square root of 4, which is 2. In order to get the same y value of 2 back, I'm going to have to plug in negative 4 now into the square root of negative x, which is my transform function, because two negatives make a positive, and voila, I get the same y value back of 2. So we see, again, on this purple parent function, p of 4 equals 2. In order to get the same y value back on my transform function, square root of negative x, I have to plug in negative 4 because it becomes negative 4, which gives me positive 2 back, the same y value. So horizontal flipping involves maintaining the same y value, right? Only you're plugging in the negative x value or the opposite sign of your original x value. And that's at the gist of what a horizontal flip is. So another way to show this is, again, using algebra like we did in the last lesson. We're going to take the original number we plugged in to get 2. So for example, we know p of 4 is 2 because the square root of 4 is 2. We're going to take that number and set it equal to our transformed function, square root of negative x. We're going to set what's inside the radical 4 for our parent function equal to what's inside of our radical of our transform function, negative x, because I know that if negative x equals 4, and I know the square root of 4 is 2, it will give me 2 back. So set 4 equal to negative x, divide by negative 1, and here we see the gist of the horizontal flip. You're ultimately dividing by negative 1, or multiplying if you want to see it that way. You're dividing by negative 1 to end up with the x value you need to plug into your new transformed function. That will give you your x value. So 4 divided by negative 1 is negative 4, and therefore x equals negative 4. If I plug that into my transform function, it will ensure that that original negative, or that negative that I put in the transformation, cancels out and gives me positive 4, and square root of 4 is equal to 2, which is the same y value I got when I plugged in positive 4 to my parent function. Again, here's where it looks like. P of 4 is 2. If I plug in f of negative 4, I also get 2 because it's canceling out this negative 1, which was my b value. If I plug in negative 4, it becomes positive 4 in my transform function, which becomes positive 2. Next up, we're going to look at a formal proof as for why this is, but for now, just remember, if you have b equals negative 1 or b is a negative in front of the x value, all you have to do is change the sign of your original x values to get the new x value that will ensure the same y value. If you have any other questions about this, let me know.